For this lesson, we're going to start looking at solving quadratic equations by graphing. And since all the solutions and roots of an equation can be identified by finding the x-intercept, quadratic equations may have 2, 1, or no solutions. So if you remember that when we were solving just for linear equations, and we were looking for the root of a linear equation, and I had my line, my root was this x-intercept right there. So the same is going to go with a quadratic equation. So if I had 2 solutions, and here's my x and y graph, 2 solutions would mean that my parabola intersects the graph at the x-axis at 2 places. So my solution would be right here and right here. A 1 solution means that the parabola intersects the x-axis at exactly 1 point. So this means that our parabola's vertex is the only point that's on the graph. And then a no solution means that our parabola never intersects the x-axis. So it could go up. And you see how the bottom of the graph never intersects the x-axis at any point. And we could draw some multiple examples. 2 solutions would be even if I had a downward graph. So where the green intersects the x-axis, I could still have a downward graph. And my vertex is my only 1 solution, or I could have a downward graph here, and it'll never cross the x-axis. So we're going to solve some quadratic equations by graphing. And our first one is that x squared minus 2x minus 8 equals 0. And I could choose some points to solve for and plug them in that way. But instead, I can go ahead and find my axis of symmetry, and I want to find that vertex point. So to do that, I'm going to use that negative b over 2a to find my x. And so I'm going to get negative 2, because the b is my negative 2, over 2, and a is just 1. So I get 2 over 2, which equals 1. So I know that the first part is 1. And then my y is going to be, if I have 1 squared minus 2x, or 2 times 1, excuse me, minus 8. And when I simplify this, I'm going to get 1 minus 2 minus 8. So 1 minus 2 is negative 1, minus 8 is negative 7. So my point, I need to go to 1, negative 7 as my vertex. And when I graph a parabola, I can always move the graph a certain way. And so I'm going to start at this original vertex point, and I'm going to go over 1, up 1, and I'm going to make a point. And then from that point, I'm going to go over 1. I'm going to go over 1, up 3, so 1, 2, 3. And then from this point, I'm going to go over 1, up 5. And then I could even go over 1, up 7, if you see that pattern. So that's always just going to be for parabolas, that I can go 1, 3, 5, 7. As long as you have the vertex, you can always move these points. And since parabolas are symmetric, I can do the same thing on the other side. So I can go over 1, up 1, then I can go over 1, up 3, over 1 up 5. And now I can connect my points. I can graph my parabola. And I see that my roots are right here at -2 and 4. So to solve this equation, my roots are -2 and -4. And we're going to write that as -2, 0, and 4, 0, because that's where my parabola crosses my x-axis. I also forgot to mention that I knew that the parabola was going up because my a was positive here, so I knew that it was opening upwards. So for this example, we have x squared minus 4x plus 3 equals 0. So to find this solution, I'm going to use my same formula, so negative b over 2a to find my x coordinate. So I'm going to get negative 4 over 2 times 1, and I get 4 over 2, so I'm going to get 2 as my x coordinate, and then I'm just going to substitute that in to find that y coordinate pair. So I get 2 times 2 squared minus 4 times 2 plus 3, and I get 4 minus 8 plus 3, so 4 minus 8 is -4, plus 3 is -1. So I have -2, -1 is my vertex. So I'm going to graph my vertex. I'm going to go 2, -1. And I know that my parabola is going to go upwards because it's a positive a. So I'm just going to go to that over 1, up 1, over 1, up 3, and then over 1, up 5. And I'm going to do the same on the other side, over 1, up 1, over 1, up 3, and then over 1, up 5. I'm going to connect my points, and I see that my intercepts are right here at 1, 0 and 3, 0 as my roots of the equation. For this example, we have x squared minus 6x minus 9. So I need to solve it for 0 because that's how I'm going to be able to find all my roots. So I'm going to rewrite the equation to say x squared minus 6x plus 9 equals 0. So all I did was I added that 9 to the other side. And now I can solve for my vertex. So I get a -6 over 2 times 1, so I get 6 over 2, which equals 3. Then I'm going to get 3 squared minus 6 times 3 plus 9. So I get 9 minus 18 plus 9. So 9 minus 18 is -9. And then I get plus 9, which equals 0. So my vertex is at 3, 0. So I'm going to go 3, 0. And if I know right away that my parabola is going to go upwards because I have a positive slope, or a positive a. However, I also recognize that my vertex is on my x-axis. So I'm going to have one unique solution here, and I can go ahead and say, hey, my solution's going to be 3, 0. Like that is the one root. I don't even need to graph the rest of the parabola because I see that it's automatically going to be on the x-axis. Go ahead and pause the video, and I want you to try this one on your own. So we're going to rewrite this as x squared plus 8x plus 16 equals 0. I'm going to solve for my vertex. So I have negative 8 over 2 times 1. So I get negative 8 over 2, which equals negative 4. And then I'm going to get that I'll have negative 4 squared plus 8 times negative 4 minus 16. And when I simplify, I get 16 plus a negative 32 minus 16. And so 16 plus a negative 32 is negative 16. But I forgot to add that that's actually a plus 16 at the end of my equation sign because it's plus 16 right here. So I went ahead and changed that. So I have a negative 16 plus 16, which equals 0. And so if I was to graph negative 4, 0, I see that my vertex is on my x-axis, so my root is negative 4, 0.